So good morning everyone. We are all gathered here today for the purpose of attending an online special lecture program conducted under DBT Star College scheme. Also, I welcome our chief guest and all the students. It is a great privilege for me to introduce the spokesperson of today's lecture, Dr. D.I. George Amalarethinam, Bursar and Director of MCA Programs, who has kindly consented to deliver a lecture today. We are very fortunate to have him in our midst as the resource person. I am very proud to state that Sir did his undergraduation in mathematics and completed MCA in the year 1988. In the same year, Sir has joined as an assistant professor in the Department of Computer Science, Jamal Mohamed College. Since then, Sir has accomplished great heights as prominent academician and one of the leading experts in the branch of computer science. So far, Sir has rich experience of 32 years and produced more than 15 PhD scholars and 55 MPhil scholars. Sir has published many books and research articles in the international and national journals and conferences. He has been the member of various academic bodies and nominated as subject expert by Bardhasan University under various schemes. Such a great personality is here today to enlighten us. I take this opportunity to thank Dr. D.A. George Amalarethinam sir and I humbly request him to address the students on the topic entitled Application of Mathematics in Digital Era. Please, sir.
Very good morning, all of you. I'm very happy to welcome you all. I also thank Professor Altaf and his team for having given me an opportunity to talk to you regarding the applications of mathematics in the present day world, that is digital era. So first and foremost, I welcome all the students of mathematics. So you are all fortunate that you have chosen the right program in your degree after completion of your +2, and you have joined in this prestigious department of our college, mathematics department. I find all the staff members who are all expertise, and you are able to gain more knowledge from them in the coming 3 years. I wish you all your stay in this campus in all these 3 years will be useful and purposeful one. I know that most of you are very much interested while joining mathematics, and few of you may be forced to take up this mathematics program. But anyway, slowly you will gain the experience and you will gain the interest. And finally, when you come out of this program at the end of the 3rd year, you will be passionate to become a mathematician. So with this brief introduction, let me welcome once again all the students and all learned colleagues to this program, which is organized under the auspices of DBT Star College scheme. Here, the topic given to me is applications of mathematics in digital era. So we have been in this era, and we are at present in this digital world. You may be getting various terms on the concept of digital, that is Digital India, One India, digital payment, digital seminars, digital currency. So various aspects are there. That is the present day world. We cannot escape from this digitalization because that is an order of the day. The entire world has been transformed into the digitalization process. But what is the base for this digitalization? Digitalization that we know it can be possible, or it is possible based on the computers only. And that too, the digital computers. Of course, we have two types of computers, analog and digital. And widely used is nothing but the digital computers, through which we do all type of transactions, all type of communications, everything. So the computers is base for this digital era. So people madly they are going for computer science programs. I should say madly, without understanding the consequences. But more than that, I could find the mathematics people, they flourish well more than the computer science graduates. You know why? Because the mathematics people, they do think logically well. They have been doing lot of exercises, mental exercises on these mathematics on various domains. But computer science people, they are working only with the machines, only with programming. Their logical part, it is not that much matching with the level of mathematics students. So that I told you initially that you are all fortunate and you have landed in the Department of Mathematics. So you should feel proud that you'll become a mathematics graduate at the end of 3 years. So mathematics is not mathematics. We can say it is the queen of all sciences that we know, because queen is very much prestigious. If you take up any kind of country, or if any kind of regime those days, the queens are more powerful. Even in England, we have the queen. Of course, we have prime ministers. All these people are there, but queen is more powerful. Like that, mathematics is queen of all sciences, any kind of sciences. Computer science is also one kind of sciences. Among all these things, mathematics is prestigious. I feel proud that I did BSc Mathematics. So here, in this digital era, the basic concept is, in this present century, it is completely transformed from industrial revolution to information technology, only to lift the economics, the economical level of the country. We have to compete with the other leading countries. There is no other go. We have to adopt the new methodology that is called as information technology. The base for computer science, I told you, it is mathematics. Because computers are functioning, especially the digital computers are functioning based on zeros and ones. 0 and 1, that's all. And it is based on mathematics, 0 and 1. Not only that, in these two digits, 0 and 1, 0 was invented by Indians way back in BC 3. It was invented. And we have various mathematicians. They have developed, they have given the shape for zeros, and they have proved it has got its own value. Even the government is giving the various gifts or various schemes on zero cost. It is not given at free of cost. Free is different, zero is different. We are able to distinguish. It is given at free of cost. It is given at zero cost. If it is given at free of cost, it does not have any value. So nobody is taken up that much importance. They do not know the importance of the or value of the product. If it is given at zero cost, then it has got its own value. The product is attached with some value that is called as zero cost. And we feel that, and we are proud that zero is invented by mathematicians. So mathematics people can claim the 50% of the development of computer science. Of course, it is drastically changed. We have the very fast, rapid growth in the development of computers, development of computer science, information technology. Whatever may be the height of computer science can claim, or mathematics people or the Indian mathematicians can claim 50% of its growth. The foundation is laid by the great mathematicians. Now the building has been raised, is being raised even now by the other people. And we have a lot of collaboration with mathematics and computer science. A period in human history characterized by the shift from traditional industry to an economy based on information and communication technology. I simply tell you, we have been working on banking transactions. You would have paid your college fees through online. You have an account. You have the card, debit card or credit card. The chip is engraved in this particular card. You have the number. And when you swipe the card or when you give that account number for transaction from one computer to another computer, we have the unique number that is engraved on this card or your account number that is sent to the bank. How it is sent to the bank? Based on the communication. We have the communication link. Mathematics is playing a vital role in communication link. And the bank is maintaining the database, the customer's database. How it is playing a vital role? Mathematics, how it is playing a vital role? It is a unique key. It's a primary key that is unique, the account number. And it should be processed in a secured way. For security, the number system is being used. Again, mathematics is coming. In between, you are getting a lot of advertisements also. On the right-hand side or left-hand side of your screen, you are getting a lot of advertisements with a lot of graphics, a lot of jimbling or going there on either side of your screen. These graphics are made up of mathematics, two-dimensional graphics, three-dimensional graphics, n-dimensional graphics. So without mathematics, avoiding mathematics, computer science is zero. So computer science is live. It has got its own life. That is because of mathematics. The period where digital technologies play a prominent role in shaping up and regulating the behaviors, performance, standards, etc. of societies, communities, organizations, and individuals. So it is uplifting, the digital era is uplifting the standards in the communities, the societies. Nowadays, we are getting the smart card for purchasing material from our ration shop. We feel proud that we are applying in online, we are getting that is admission in online. Everything is done in online. Class is also conducted in online. So we sit on a table, everything is being processed. That is, our lifestyle is completely changed as a society and also as an individual. the environment that uses digital technologies. The current era in which digitalization is predominant, you cannot avoid. Everywhere, can go everywhere, anywhere you can go. You find the concept of digitalization. The moment of history lived after creation of these main communication technologies existing can be considered the current period of history. This will become an history. Again, you will get another change. It is characterized by the technology. The term used to describe the today's era in which digital technologies are used in almost every aspect of life, every aspect. Wherever you go, suppose you would like to come to Trichy from your hometown, you can book a ticket by train or by bus. That is also done by online. You can pay the amount in online. Right? So whatever job you can going to take up, that is based on the digital technologies. Here, in this seminar, we are going to discuss some of the points on preliminaries of computers, computer programming, evaluation of expressions using data structures, that is computer logic design, discrete mathematics, algebra, use of linear block codes, role of automata theory, algorithmic approach for computation, simulation, mathematics for computer science, use of probability theory, mathematics for Google search. So probability, what is probability? It is of course statistics. Statistics is a branch of mathematics, part and parcel of mathematics. In your +2 or in your 10th standard, tossing a coin. If you get a head, what is the probability of getting a head? 1/2. What is the probability of getting a tail? 1/2. Some people may say it is 1/3 because it is hanging in between, or some crow has taken up the coin. So you can take up any kind of n probability, but definite probability is 1/2. So how it is being used for Google search? For anything and everything, we are depending on Google. It is playing a vital role in every man's life, everybody's life. The servers are installed throughout the globe. Then it gives you information in a fraction of a second. How this is done? That is also based on mathematics. Of course, the codings are written by the computer people, but the base for writing the coding is nothing but mathematics. How the algebra is used, how mathematics, discrete mathematics is used, because this digitalization process is purely based on discrete mathematics. It takes the values 1, 2, 3, 4, that is discrete. So we have the digital watch. It shows the time as 10, 12. But if you take the analog watch, we have 3 hands, hour hand, minute hand, and second hand. They're all continuously running. But digital watch, it is precise. We need not calculate. Just like that, by looking at the screen, we can say that time is 10, 12, 10, 13. Discrete mathematics, algebra, block codes, automata theory. Computer science, we do write compilers. Every language, it has got its own compilers. Some of you would have studied computer science in your +2. C program, C++ program, compile it. For designing compilers, this automata theory is required. Then Boolean logic, David Boole, George Boole. He has designed the logic AND gate, OR gate, NOT gate, NAND gate. Again, that is the basis of the logic gates of mathematics. Data structures, computer programming, all these things based on mathematics only. Now we'll take some of the great mathematicians who rendered very great works for computational mathematics. The first person is Euclid, father of geometry. He was working in a library of Alexandria, and he has written many books on geometry and number theory. Even we have the very great Indian mathematician recent days, Srinivasa Ramanujan. His great works are still not solved. Still unsolved problems are there by the great mathematician Srinivasa Ramanujan. And this person, Euclid, he has given the GCD, greatest common divisor, which is very much helpful for mathematical proof and algorithms. And another person who is called as Alvarezami, that is algorithmy, we call them in our language. On his name, this concept of algorithm is designed. Before writing any program, this algorithm is written, because the programs are written in a specific language, C or C++, Java, any language, we can write a program. But before writing the program, the logic has to be written. That is step-by-step procedure. That is algorithm. So he was working in the House of Wisdom, Baghdad. So he did great work on mathematics, especially on astronomy, geography, algebra, and arithmetic aspects. The position, so which should come first, 1, 2, 3, 4. So this person has done all these great works. Has given algorithm for arithmetic operations and for solving linear and quadratic equations. X square plus bx plus c equal to 0, quadratic equation. Tamil mediathila படிச்சிருந்தீனா இருபடி சமன்பாடுகள் அப்படினு படிச்சிருப்பீங்க. Quadratic equations. Then other person, the father of Boolean algebra, David George Boole. He is a 19th century mathematician. He has developed the Boolean logic and Boolean operators, or and not, in our regular term. A or B, idli or dosa. Idli ladi dosa. Idli or dosa. For dosa, we need chutney and sambar. And not gate is not dosa. That means I want idli. So these are all the real life aspects. These real life aspects are incorporated in mathematics. And these logics are being incorporated for designing the logic gates. The logic gates is highly required. The logic gates are the one was the base for designing the integrated chips. Then next one, father of computing, Alan Turing. He is a 20th century mathematician. So he has designed a computer that is called as Mark I. And he has written the book on computing machinery and intelligence. That is the foundation of artificial intelligence. Nowadays, the new term or terminology that is being used by the people, that is called as AI, artificial intelligence. We try to make the computer to think. But it is not possible, but still, we try the maximum limit. We give all type of input. Based on that, the computer will produce the output. So everything is hands on the human being, but still we try to derive from the system. That is artificial intelligence. Another one is recursion theory, especially in our factorial, finding out the factorial. We try to use the recursion theory. Kurt Gödel, considered the greatest mathematical logician of the 20th century. He was one of the founders of the recursion theory those days. And how the computers are defined. Digital era, without computers, we cannot do anything. Without system. Nowadays, even mobile phones we do. Mobile phone is one kind of the computer, pocket computer. So it is electronic device, fast electronic calculating machine, operating under the control of instructions stored in its own memory. It accepts data from the user and processes them according to the instructions given by the user. Process the input according to the instructions given by the user and produces the results. And these results will be stored in some place. And if you take up the facts of computer science is as much about computers as astronomy is about telescopes. This is given by Dijkstra, who is another mathematician. So he is known for finding out the shortest route between the two places, source and destination. So what is the shortest route between Trichy and Chennai? What is the shortest route between Trichy and Bangalore? So this is given by Dijkstra, who is also a mathematician, who has made a lot of contributions in computer science also, especially in the area of networks. In general, the study of processing of information includes many areas, particularly mathematics. In another side, computers turn mathematics into an experimental subject. Then what are all the advantages of using computers? The first advantage is speed. The first advantage is speed. So it is very fast, quick. And second one, reliability. The results are reliable. And third one, we have consistency. This consistency is nothing but consistently it is giving the results. Right? Consistently, the same amount of the same type of results, right? The same type of results. If it is a smaller amount of data or it is a larger amount of data, the consistency is playing a vital role. We need consistent. Sometimes, somewhere for a smaller set of data, it may give the results correctly. If you take up a larger set of data, the results may not be fruitful. So we need the consistent results. Then storage. Storage is another important aspect. The results have to be stored permanently. Right? The results have to be stored permanently. the computers facilitate the storage. And nowadays, we have the cloud storage. Nowadays, we need not invest much on the storage. Everything is available on the cloud. Cloud means it is not the sky. It is somewhere. Some millionaires or billionaires, they are investing huge amount. Some bigger organization, they are investing the huge storage. For simple, I can give you one example. So we have jewels. It should be protected. It should be stored. We have some jewels at home. It is not secured when they are stored in our home or at our home. So the banks are keeping the lockers. Okay? The banks are keeping the lockers. And we hire one particular box in the bank and we keep our jewels and they are secure. Similar to that, we have the cloud computing where our data is kept. What is the size or what is the capacity we require? What is the amount of storage we require? Based on that, we have to pay the rent. We need not invest much on purchasing the storage, purchasing the memory. That can be stored elsewhere, but it is protected. And communication. Quick. Nowadays, nobody is writing the letters. For communication, we are using short message service, SMS. We are giving mails. From the college in the admission season, we don't send letters. We send only SMS and we are sending mails. And you are supposed to see the SMS. You are supposed to see your mail. And you have to act accordingly. You have to pay the fees. And you can find out the classes, when the classes will commence. All these notifications are sent only through SMS or through mails. So communications are playing a vital role. So these are all the important advantages of using computers. And all these aspects are tightly related to the effective usage of mathematics. It may be a speed or reliability, consistency, storage, or communication. We'll see. Everything is closely related to the effective use of mathematics. And how the mathematics is playing a vital role in computer science. Today's computer systems are more complex and more rapidly evolving, quickly evolving. Thus, the need for tools and techniques that assist in understanding the behavior of the systems. This will answer the questions such as cost and performance of the systems. Two ways analyze the characteristics of the computers. One is on experimental basis, another one is on modeling basis. There are three basic areas of mathematics related with computer programming for experimental and modeling. First one, the theoretical aspect, we have mathematical modeling. What do you mean by mathematical modeling? ஒரு பெரிய ப்ரோக்ராம் கொடுப்பாங்க, ஒரு பெரிய ஒரு 3 pagesக்கு வந்து ஒரு பெரிய எஸ்ஸே கொடுப்பாங்க. ஸோ என்ன பண்ணணும், ஃபர்ஸ்ட் என்ன பண்ணணும், செகண்ட் என்ன பண்ணணும், என்னென்ன கண்டிஷன்ஸ் இருக்கு, என்ன வேணும் உங்களுக்கு, what is your objective. All these things are given, that is elaborately given in a form of 3-4 paragraphs or 3-4 pages. When you give it to mathematics person, mathematics graduate, he will simply write 3 equations with 1 objective functions. ஒரு objective function எழுதுவாரு, இதான் உங்க objective, subject to first one, second one, third one. That's all. 3 லைன்ல முடிஞ்சிடும். ஒரு 3 பக்கம் எழுதியிருக்க பெரிய ப்ராப்ளத்தை 3 லைன்ல மேத்தமேட்டிக்ல ஒரு 3 வேரியபிள் 4 வேரியபிள் போட்டு he will write it and give it to them. That is called as modeling. Of course, physics, chemistry, engineering principles are incorporated. Second one is computation. providing the input to what experiments to try. Whenever we do some experimentation, the results have to be tabulated. Again, mathematics is involved. And it is providing the feedback to the theoreticians. Third one, experimentation. Experimentation is nothing but whether the theorem is working well, whether the theory is working well. Verifying the computations. Once verified, computations need not be verified again in similar cases. சில பேர் என்ன பண்ணுவோம் அப்படின்னா, கடையில எல்லாம் போனீங்கன்னா, ஏதாவது ஜாமான் வாங்கினீங்கன்னா கால்குலேட்டர்ல போடுவாங்க. அதுக்கப்புறம் தனியா ஒரு பேப்பர்ல வச்சு அந்த 4 ஜாமான் வாங்கினீங்கன்னா 4 ஜாமானையும் கூப்பிட்டு திருப்பி அதுல ஒரு கால்குலேஷன் போடுவோம். நமக்கே தெரியாது அது அவன் வந்து கால்குலேட்டர் நம்பலையா இல்ல அவனோட கால்குலேஷன் நம்பலையா அப்படிங்கிறது தெரியாது. somehow you like to verify நம்ம போடுறதும் கால்குலேட்டர் கொடுக்குற ரிசல்ட்டும் கரெக்டா இருக்கா அப்படின்னு சொல்லி. So that is experimentation. And junction of mathematics and computer science, the digital era. We have mathematics. Set theory படிச்சிருப்பீங்க. You would have studied set theory. Set A is called mathematics. Set B is called computer science. The intersection of set A and set B is theory of computing. That is pure mathematics. This computer science and the mathematics and the operation, integration. That is intersection. Intersection. That is called as theory of computing. Going to combine computation and mathematics. What is the need for digitalization process? Numerical simulation fills the gap between physical experiments and theoretical approaches. Many phenomena are too complex to be studied exhaustively, largely by either theory or experiments. Computational approaches allow many outstanding issues to be addressed that cannot be considered by the traditional approaches of theory and experimentation alone. So we have many outstanding issues which cannot be solved by using traditional method. For example, you would like to find out the matrix inverse for 100 by 100 matrix. So how is it possible? 3 by 3 matrix கொடுத்தாலே நம்ம தப்பா தான் போடுறோம். 100 by 100 matrix you have to find out the inverse. How do you find out? You have to depend on the computers, right? Despite the fact that mathematics and computer science are strongly intertwined, closely related, and helping each other for a better understanding. The computer science with mathematics emerged from the fact that mathematics and computer studies are linked to each other. We cannot avoid mathematics for studying computer science. Computer science மட்டும் இல்ல, physics படிக்கிறதுனால mathematics வேணும், chemistry படிக்கிறதுனால mathematics வேணும், எது படிக்கிறதுனால mathematics வேணும். Without mathematics, no science exists. You can say botany and zoology, but when you go for higher level in biotechnology, microbiology, or MSc botany, MSc zoology, we need a lot of mathematics. They are depending on mathematics. Evaluating arithmetic expressions using stack. Some of you would have studied computer science in your plus 2. What is stack? Stack is nothing but lost in first order. Keeping your hand and you can pile up of books on your hand. வரிசையா புக் அடிக்க வச்சே வாங்க மேல. ஒன்னு உங்க கையில வரிசையா புக் மேல அடிக்க வச்சுட்டே வந்தீங்க அப்படின்னா எது லாஸ்ட்ல வச்சீங்களோ அந்த புக்கு தான் ஃபர்ஸ்ட் எடுக்க முடியும். எனக்கு 4வது புக் வேணும், 2வது புக் வேணும் அப்படின்னா மீதி புக் எல்லாமே கீழே விழுந்துடும். So we can enter the data only on the top. We can remove the data only from top of the stack. So this is highly required for evaluating an expressions. So these are all infix expression, postfix, prefix, and these are all the things those people who have studied computer science in your test 2 are able to understand the prefix notation, postfix notation, and infix notation. Infix notation is common. That is what we are writing in our regular expressions. They are called as infix notations. Right? So that will be converted into postfix notation. Right? And these postfix notations are being evaluated. The data structures, especially stack, for any kind of arithmetic evaluation, the postfix notation is being used. These conversions, infix, postfix, and prefix. So we are using always we are using the brackets. Infix na ஒண்ணும் இல்ல, operator வந்து வேரியபிளுக்கு நடுவுல இருக்கும். Postfix na வந்து வேரியபிளுக்கு அப்புறமேட்டு இருக்கிறது postfix. Prefix அப்படிங்கிறது வேரியபிளுக்கு முன்னாடி வந்து இருக்கிறது வந்து prefix. And the methodology, this is an example for first we are entering 1, we are entering 2. So this is a expression to be evaluated. 1 plus 2 star 3 minus 4. Evaluate பண்ணணும். Postfixல எழுதுறப்ப பாத்தீங்க அப்படின்னா, so 1, 2, 3 star plus 4 minus. Right? So first என்ன பண்ணணும் அப்படின்னா, you have to perform the order of evaluation. Order of evaluation, the first we take up only multiplication or division. Then we go for addition and subtraction. So first value is entered into the stack. Then second value is entered. Then third value is entered. அதுக்கப்புறம் என்ன பண்ணணும்? 2 and 3 are to be multiplied. 2 and 3 multiply பண்ணணும் அப்படின்னா, the last 2 from the stack, 3 and 2 multiply equal to 6. Now 6 is available. சரியா? Stackல 6 available. அடுத்து என்ன பண்ணணும்? That 6 should be added by 1. Now 7 is available. Right? So star போட்டாச்சு, addition போட்டாச்சு. அடுத்த next value, it has to be entered. 4. 4 has to be entered. Then 7 minus 4 equal to 3. So this is how the evaluation is being carried out within the computers. So this process is based on algorithms. Another one is George Boole. He has given the Boolean algebra. He has developed the logic and Boolean algebra. These variables to count either true or false. ஒரு ஸ்டேட்மெண்ட் கொடுக்கிறோம், இருக்கா இல்லையான்னு சொல்லுப்பா அப்படின்னு சொல்றோம் இல்லையா, அதான் ட்ரூ ஆர் ஃபால்ஸ். இல்ல நாளைக்கு வரியா வரலையா, நாளைக்கு பாக்குறேன் சார் அப்படின்னு சொன்னா என்ன அர்த்தம்? He is not giving the exact results. வரேன் வரல அவ்வளவு. True or false. Shannon showed how to map Boolean algebra to digital circuits. That is the second image. The primitive functions of Boolean algebra, undo function பாத்தீங்கன்னா, both the inputs should be 1. அப்பதான் output 1 ஆகும். The table, undo table பாத்தீங்கன்னா 0 and 0, it is giving only 0. 0 and 1, 0. 1 and 0, 0. 1 and 1 தான் 1. ரெண்டு இன்புட்டுமே வந்து 1 இருக்கணும், அப்பதான் வந்து அவுட்புட் பண்ணுவாங்க. Similarly, OR operation. where it is used, basic circuits use ஆகுது, security use ஆகுது, communication use ஆகுது, for checking the status of the device use ஆகுது. Everything is based on the Boolean algebra. Whether the status of the counter is free or busy, status of the memory is free or busy, everything can be checked by using the Boolean. Or operation பொறுத்தவரையில் any one of the two inputs is 1, then output will be 1. ஏதாவது ஒரு input வந்து left hand side இருக்கிறது input, right hand side இருக்கிறது output. 0 or 0, that is 0. ரெண்டுமே 0. 0 or 1 is 1. 1 or 0 is 1. 1 or 1 equal to 1. Not a பொறுத்தவரையில் 0 இருந்துச்சுன்னா 1, 1 இருந்துச்சுன்னா 0. அவன் இருந்தா நான் வரமாட்டேன் சார், நான் இருந்தா அவன் வரமாட்டான் சார். That is not. So these are all mathematics. These are all computer science. Digital systems, then discrete சொன்னேன். ரெண்டு கிராஃப் இருக்கு. ஒன்னு வந்து டிஜிட்டல், another one is analog. Digital பாத்தீங்க அப்படின்னா -5 to +5. Right? We have the velocity and time. So it is rising. It is coming. It is giving to 0, coming to 0. Then it is going up. That is called as clock pulses. Computer science lo solluvom. It is clock pulses. It is precise. Correct அந்த இடத்துல வந்து கீழே இறங்கிடும், திருப்பி அந்த இடத்துல மேலே ஏறும். டிஜிட்டல். அனலாக் அப்படி இல்லை. இந்த இமேஜ் பார்த்தாவே தெரியும், a kind of zigzag image. Values vary over a broad range continuously. It is discrete, it is continuous. And representations of digital design, Boolean algebra. The values are 0 and 1. The variables are ABC, XYZ. Operations பாத்தீங்கன்னா not operation, and operation, or operation. Not அப்படிங்கிறது எப்படி எழுதுவோம் அப்படின்னா it is x bar. X and y is written as x and y, or sometimes x, y. And அப்படின்னு எழுதுவோம் a and d. இல்ல எதுவுமே எழுத வேணாம், x and y கம்பைன் பண்ணி எழுதினாவே அது வந்து and operation. X or y is written as x plus y. It is not addition symbol, it is or symbol. And the plus அப்படின்னு போடுறது, it is not representing the addition, it is representing the or value. And that is a derivation. We are adding, we get some carry, we get some sum. Right? Sum is a result. Apart from that, we are getting carry also. Right? So A, B, two inputs. Right? And we get the values. These are all the basic mathsல வந்து theorem னு சொல்லுவோம், proof னு சொல்லுவோம், then commutative law, associative law, distributive law சொல்லுவோம், De Morgan's law. Then basic theoremsல வந்து பாத்தீங்கன்னா x plus 0 equal to x. It is not plus, it is or operation. X or 0 equal to x. X or 1 equal to 1. X may be 0 or 1. Either it can be 0 or it can be 1. If it is 0, 0 or 1 equal to 1. If it is 1, 1 or 1 is also 1. Then x plus x dash. If x is 0, x dash equal to 1. So 0 or 1 equal to 1. Then x dash whole dash. X is equal to 0. X dash equal to 1. Then 1 whole dash equal to again 0. So x double dash equal to x. Then x or y equal to y or x. Then x plus y plus z equal to x plus y plus z. Then x into y plus z equal to x into y plus y x into z. These are regular theorems, right? So these identities define intrinsic properties of Boolean algebra. They are very useful in simplifying the Boolean expressions. The Boolean expressions are very much required for finding out the combinations in the logic gates. Then the discrete mathematics. This is nothing but a puzzle. Puzzle. So to give some work to our brain, right? So we are using puzzles. That is one kind of mathematics. This is a network, right? This is a network. These are all computers connected. Servers are in between. The data can be stored. It can be sent to various places. This is the basics based on discrete mathematics. This is a cube. We're getting out the same color in every side. That is also mathematics. This is called as a key. Is nothing but the security. Only to indicate the security, we are using the key. Then this is gaming. Cards, playing cards. Solitaire games. Solitaire. Even in mobile also, we have a lot of apps on solitaire. That is also based on mathematics. So it is a mathematics of computers. Discrete mathematics abdinave. Discrete abdinave computers. Discrete abdinave digital. Digitalization. Discrete means digital. It is the mathematics of digitization, mathematics of computers. Some areas include graph theory used in networks. Networks, we are using the term, computer science people, we are using the term networks. Mathematicians, you are using the term graph theory. The same graph theory is applied in computer networks. Counting techniques, coloring theory, game theory, and many more. It is finite. It handles distinct chunks of information. You may talk about the schedule of flights leaving Trichy, but not the acceleration of one of those planes. That is discrete. 8:25, there is a flight from Trichy to Bangalore. But what is the speed of the flight? Nobody knows, except the pilot. That is called as acceleration. 8:25 in the speed like Colombo. 8:25 flight Colombo. That is discrete. Acceleration is continuous. Then logics and proofs. Logic, it is a propositional logic, first order logic. Proof, random type of proof. Mathematics people, you may know very well. Proof of induction, proof of contradiction. Induction is what step by step derive proof of induction. Proof of contradiction, assume proof. That is called as proof of contradiction. So these are all very much used in artificial intelligence, databases, circuit design, and algorithms. These proofs are highly required. And number theory. Number theory படிக்க ஆரம்பிச்சிருப்பீங்க. Numbers, number theory is playing a vital role in every field of computer science, every domain of computer science. The Euclidean theorem, Euclidean algorithm and prime numbers. Prime numbers are base security. நிறைய தியரம் நம்ம படிப்போம் மேத்தமேட்டிக்ஸ்ல. எதுக்கு இந்த தியரம் படிக்கணும்னே தெரியாது. ஆயிலர்ஸ் தியரம் படிப்போம், சைனீஸ் ரிமைண்டர் தியரம் படிப்போம், யூக்ளிடியன் தியரம் படிப்போம், நிறைய டிஃபரன்ஷியல் ஈக்குவேஷன்ஸ் எல்லாம் படிப்போம், இன்டகிரேஷன் படிப்போம். எதுக்கு இன்டகிரேஷன் படிக்கிறோம் தெரியாது. எதுக்கு டிஃபரன்ஷியேஷன் படிக்கிறோம்? இல்ல பார்ஷியல் டிஃபரன்ஷியேஷன் கொஞ்சம் டிஎஸ் ஆச்சு போடுவாங்க, டோ அப்படி. எதுக்கு இதெல்லாம் படிக்கிறோம் அப்படின்னா, they are highly used in the reservoir modeling. ஒரு டேம் கட்டுறாங்க அப்படின்னா we need the partial differentiation. Then we are constructing a bridge. ஒரு ரிவருக்கு மேல ஒரு பாலம் கட்டுறாங்க அப்படின்னா we need the differentiation. Find out an area, we need integration. So these are all various applications of mathematics. எல்லா ஃபீல்ட்லயும், எந்த ஃபீல்ட்ல மேத்தமேட்டிக்ஸ் இல்ல? எவ்ரி ஃபீல்ட் we need mathematics. சாதாரண ஒரு பெட்டி ஷாப் வச்சிருக்காரு ஒருத்தர் அப்படின்னா definitely he is using mathematics. பணத்தை கவுண்ட் பண்றாருன்னா மேத்தமேட்டிக்ஸ். Then if a person is searching a particular information from the computers through Google or to Alta Vista, through Yahoo, very extreme. But both of them are using the computers, both of them are using the mathematics. So we have modular arithmetic, Chinese remainder theorem, check digit scheme, cryptography. Cryptography அப்படிங்கிறது that is mainly used in security purpose. Data security, storage security, information security. எல்லாத்துக்குமே we need the cryptography. Cryptography அப்படிங்கிறது two concepts. One is encryption, another one is decryption. நான் இங்கேருந்து ஒரு மெசேஜ் அனுப்புறேன், கான்ஃபிடென்ஷியல் மெசேஜ். அதை யாரும் நடுவில் பார்த்துடக்கூடாது அப்படின்னா என்ன பண்ணணும்? We need cryptography. We need coding theory, data structures. For all these things, the number theory is highly required. Number theory and computer security. That's what happened. Number theory has got many applications in computer security. Setting up encryption keys. நான் ஒரு என்கிரிப்ஷன் கீ போட்டு அனுப்புறேன். ஒரு சாதாரண மெசேஜை பார்த்தீங்கன்னா எல்லாத்துலயும் ஏ ஆட் பண்றேன், பி ஆட் பண்றேன், சி ஆட் பண்றேன். அதை படிக்க முடியாதபடி நாட் இன் ரீடபிள் ஃபார்மேட் அதை அனுப்புறேன். அது நடுவில் யாரும் இன்டர்பிரட் பண்ணிடக்கூடாது. ஹேக்கர்ஸ் இருப்பாங்க. இப்போ ஒரு கண்ட்ரில இருந்து இன்னொரு கண்ட்ரிக்கு ஒரு இன்ஃபர்மேஷன் பாஸ் ஆகுது, மெசேஜ் அனுப்புறாங்க அப்படின்னா நடுவில் the information will be hacked. Government is sending an information to the military. பார்டர்ல மிலிட்டரிக்கு அனுப்புறாங்க, ஒரு இன்ஃபர்மேஷன் அனுப்புறாங்க அப்படின்னா அதை என்ன பண்ணுவாங்க? நடுவில் டேப் பண்ணுவாங்க. டெரரிஸ்ட் or terrorists, they communicate each other. That is being tapped by the government. ரோஜா படம் பார்த்திருப்பீங்க. அது அரவிந்த் சாமியோட ரோல் என்ன? கிரிப்டாலஜிஸ்ட். When the terrorists communicate with each other, that it has to be tapped and decoded, submitted to the government. Adan vela. He is called as cryptologist. This encryption is mainly used for transferring messages securely. The practical side of number theory is nothing but modular arithmetic, prime numbers, Chinese remainder theory. These are all the cryptographical methods. The RSA is a very pioneer security algorithm. It uses the various theorems, the practical side of number theory concepts like prime number theorem, modular arithmetic, congruence relations, modular inverse, Euler's theorem, post-modular exponentiation, Miller-Robbins primality theory test, integer factorization, and Chinese remainder theorem. Not only that, we have magic square, we have magic rectangle. These are all widely used in computers circuit. This is number theory, and which is used in RSA cryptography. So we have two prime numbers, and we are using modular arithmetic, post-modular exponentiation, congruence relations, and Euler's. Putting together, when you combine together, you are getting the RSA algorithm. There is no new concept. The concept is taken out from the number theory. Then counting. It is nothing but set theory. Counting. Set A, set B, set C. Sets and functions. Combinations, permutations, and we are using a number of theorem, binomial, Poisson, normal, various theorems are there. Counting by mapping equations. These concepts are widely used in probability theory, algorithms, and data structures. This counting used in algorithms, especially sorting methods. We have a number of sort, double sort, insertion sort, selection sort, merge sort, bucket sort, rapid, then big sort. Various sorting methods are there. All these sorting methods, they are using only number theory. And among these, which algorithm is running very fast, that can also be found out. Graph theory, already I have told you that the graphs, relations, and mathematics people, they say that it is graphs, and computer science people, it is called as a network. Because we are using the term graphs, but ultimate aim is to define the networks. Graphs, relations, degree sequence, Eulerian graphs, isomorphism, trees matching, coloring. So we try to color the nodes, the source, the destination, the points, the connection points. All these things are colored only for differentiation. Another one is we have the tree structure. It is called as a binary tree. Binary tree has got two leaves, two siblings. Node A has got two siblings. Node B has got two siblings. Node C has got two siblings. And these last level nodes are called as leaf nodes. It is widely used in computer networks, circuit design, and data science. And how these graphs are using in computer science? The term graph is used in a different sense in mathematics to mean a chart displaying numerical data such as a bar graph. So various graphs are there, point graph, line graph, then bar graph, pie chart. Various graphs are there. In computer science, networks are drawn using circles or dots, technically called as nodes, to denote the objects. Graphs are also no points. networks, we are using the term nodes. Right? That is the computer. The computer is there to receive the data and to send the data and to broadcast the data. Broadcasting அப்படின்னா ஒரே சமயத்துல எல்லா இடத்துக்கும் போறது. Same time, it will send the data. Broadcasting, radio broadcasting அப்படின்னு சொல்லுவோம். Same time, news எல்லா இடத்துக்கும் போகும். It is called as broadcast. The lines between the nodes indicate some sort of relationship between them. Node A and node B, they're all directly connected. But it has got its own meaning. The data can be sent directly. The communication is quickly carried out. There is no intermediate node. Various meanings are there. When they are not interconnected, then another interpretation can be given. Then usage of graphs, trees in communication networks. An important application of graphs in computer science is modeling communication networks. Generally, vertices will represent computers, processors, and switches. Edges represent the wires, fiber, and other transmission lines. Edges are the line connection between the two nodes. They are called as edges. Vertices are called as nodes. They are called as computers. Angirundu wire varum. That is a shielded wire or wireless. It may be optical fiber or any kind of transmission line through which the data will flow. That's why the data flow. Mostly at home, we are using the television lines. The television lines are used to transmit the data in analog fashion. Again, it has to be reconverted into digital. For some kind of networks like internet, the corresponding graph is enormous and largely chaotic. Throughout the world, I am working in one network. College now our system work pandren. It is connected in a network. My system is connected in a network. But I am able to communicate a person who is working in Australia. How this is done? He is working somewhere in Australia in another network. My network and his network both are interconnected. How is it possible? Through internet. So we have a lot of switches, we have a lot of modems, we have other devices. Then communication is established between Jamal Mohamed College and Australia. And I can directly communicate with a person who is working elsewhere throughout the globe. In online, I am able to communicate. Then Distor's algorithm, I have told you, is a great mathematician working for the shortest path. What is the distance between the Trichy and Chennai? 350 kilometers. Okay. What is the shortest route? He is the person to give the shortest route. He will find out all routes, and he is giving one algorithm. Using that, by using the Distor's algorithm, you can reach the destination in a shortest path. The same methodology is using in Google. We are using the Google map. The Google map, how it is working? By using Distor's algorithm. For a given vertex in a graph, the algorithm finds a path with the lowest cost, the shortest path, between the vertex and every other vertex. One vertex lende ella vertex. One node lende ella node. Distor's algorithm can be used to find out the shortest route between one node and other destination node for communication. Yen poringa, which is our nearest tower, mobile kondu poringa. mobile kondu porappa, which is your nearest tower, you are connected with that tower. College la irukumbodhu college pakkadila ulla tower la varum, veetla irundha veetu pakkadila ulla tower la varum. Enakku tower kedaikala sir, na veetla poi pesren solrong illaya, which is connected with the nearest communication. And this is a graph, this is a network. How to send the data efficiently? That is done by means of distance algorithm. Now shortest route. When you take up the shortest route, it will reach quickly. Then algebra, that is used in programming, databases and data mining, set, function, relation, etc. What is the need for algebra? It is the basis for mathematics, which is a tool for reasoning. Now images kuduthirupanga, you have to distinguish the images. And it is used in computer science also, especially in discrete mathematics. It is an invisible logic. And we are using the linear block codes, which are used in error correction and detection schemes, especially while the communication is taking place. Again, ஒரு set of files அனுப்புறீங்க, ஒரு data அனுப்புறீங்க, ஒரு record அனுப்புறீங்க. Record அனுப்பும்போது at the receiving end, some bits may be lost. This bit would have been lost at the time of delivery or at the time of sending itself. நீங்க வந்து ஒரு 16-bit data அனுப்புறீங்க. அந்த 16-bit data reach ஆகுறப்ப பாத்தீங்கன்னா உங்களுக்கு வந்து 14 digits ஆ இருக்கு, 14 bits ஆ இருக்கு. 2 bits have been lost. This loss would have been occurred at the time of sending the data or at the time of receiving the data. We do not know. But how this can be found out? By using the linear block codes methodology of error correction and detection methods. These linear block codes allow for more efficient encoding and decoding algorithms. Linear block codes are an important aspect of coding theory. The blocks, the elements in the binary linear block codes are called code words. So these are all the various coding theories and Hamming codes, which are widely used in error correction and error detection. And he was working as a theoretist in AT&T Bell Laboratories, American Telephone and Telegraphs Bell Laboratories. Then Hamming discovered a solution that would allow a computer to overcome an input error and restore the original input without having the program to restart. Yes, the codes of the Hamming codes are the non-trivial linear block codes. Okay. Then the mathematical models for computations. The first one is automata theory. Second one is computability theory. This computability theory is a base for designing the computers. The complexity theory and applications. This complexity theory is used to find out the level of the algorithms, the strength of the algorithms, the space complexity, time complexity, how it is powerful, how the algorithm is powerful. That can be found out by using the complexity theory, whether it is polynomial or non-polynomial. All these things can be found out by using the complexity theory. Then simulation, that is another major area. Simulation அப்படிங்கிறது ஒண்ணும் கிடையாது. சிமுலேஷன் அப்படிங்கிறது டேர்ம் வேணா உங்களுக்கு புதுசா இருக்கலாம். சிமுலேஷன்னா வந்து ஒரு பெரிய பில்டிங், கவர்மெண்ட் பில்டிங் கட்ட போறாங்க. ஃபார் எக்ஸாம்பிள் நியூ பார்லிமெண்ட் பில்டிங் இஸ் கோயிங் டு பி கன்ஸ்ட்ரக்டட் அப்படின்னா ஒரு ஒரு இமேஜ் ஒன்று காமிப்பாங்க, ஒரு மாடல் ஒன்று காமிப்பாங்க. சரி, ஒரு மாடல், ஒரு டிசைன் வித் ஃபுல்லா சேம் மாடல் will be designed in a thermocol or in plaster Paris. The model will be designed and it will be placed on the table. The table vacha theriyum indha mari dhaan irukum. This is the entrance. Indha mari rooms will be like this. That is a simulated model. Actual construction eppadi irukka podhu adha simulated model. That is called as mathematics queuing theory, inventory theory. Inventory, for example, it is widely used in various real life aspects. For a departmental store, when the stock has to be placed, he is making the retail sales, but he has to get the commodity from the wholesaler. For example, you are using a car. The car has got a depreciation value. So when it has to be sold out. So these things are called as inventory theory. For that, mathematics is used. And nowadays, you can see in every supermarket, we are using these kind of order placing, then stock taking, then material delivery. Everything is based on digitalization process. From home, we are able to place the order. And they are checking the order. The clerical staff is checking the order because he is making everything on bills. Bill போக போக வந்து ஸ்டாக் ரெடியூஸ் ஆயிட்டே வரும். ஸோ நீங்க வந்து ஒரு இது ஆர்டர் பிளேஸ் பண்றீங்க அப்படின்னா whether it is available or not, that can be easily checked up. Otherwise, the order would have been placed or order has to be placed, then getting the order, getting the inventory, keep them, and that can be distributed to the customers. And this is advancement in the simulation of complex scientific and engineering systems provide an unparalleled opportunities for solving major problems that is facing our nation in the 21st century, especially in these COVID-19 situations. Next one, another digital aspects is nothing but computer graphics. Serial பார்க்குற எல்லாரும் பார்ப்பீங்க, சினிமா பார்ப்பீங்க. அதில் பார்த்தீங்க அப்படின்னா கம்ப்யூட்டர் கிராஃபிக்ஸ் அப்படின்னு போட்டு ஒருத்தர் பேர் போட்டிருப்பாங்க, அனிமேஷன் அப்படின்னு போட்டு ஒருத்தர் பேர் போட்டிருப்பாங்க. வாட் இஸ் த மீனிங்? த கம்ப்யூட்டர்ஸ் ஆர் ரிக்வயர்ட். இதெல்லாம் வந்து பார்த்தீங்கன்னா கம்ப்யூட்டர்ஸ்ல பண்றாங்க. இங்கேருந்து வந்து பாத்தீங்கன்னா ஒரு ஹீரோ வந்து இங்கேருந்து பறந்து போய் 200 அடி பறந்து போய் அடிப்பார் ஒருத்தர். How this is done? That is by using graphics. கிராஃபிக்ஸ்ல பண்ணிட்டானுங்க அப்படின்னு சொல்லுவோம். என்ன கிராஃபிக்ஸ்ல பண்ணிட்டாங்க அப்படின்னா by using computer graphics. For that, we need the mathematics. So algorithms, mathematics, data structures that enable computers to make pretty pictures. அப்படியே அது வந்து போட்டோகிராஃபா இல்ல பிக்சரா அப்படிங்கிறது நம்ம வந்து டிஜிட்டல் ஆர்ட்டா இல்ல போட்டோகிராஃபியா அப்படிங்கிறது தெரியாது. I will show one or two images. Functions, routines to draw line or circle. Lot of methods are there. to draw a line, to draw a circle. To draw a circle, we are using two endpoints are required to draw a line. For drawing a circle, we need the center point and the radius. We need the center point and the radius. For that, we are using the circle. Circle is one kind of geometric model. Line is also one kind of geometrical model. We have a triangle, we have rectangle, square, all these things are there. These are all the geometric models. So we have pull down menus. When you are using the online transactions, we are using the pull down menus. That is one kind of graphics. 3D coordinate systems, X, Y, Z, X coordinate and Y coordinate. We are using X, Y, and we are using Z coordinate, right? And we have the libraries, graphics libraries, OpenGL, DirectX, then IGL Plot10, IGL Plot20, then GKS. These are all various graphics libraries are used. And nowadays we are using the GPUs are also available. That is a graphics card. People who are working with animation, they are using graphics card. Right. So that is nowadays many people are working on animations, visual effects. Right. So for that, they have to make the geometric model on paper by using X coordinate, Y coordinate, Z coordinate. Based on that, it can be transformed into computers. So we have creation of objects, vertices, that is a node, edges, lines, faces, box, sphere, cylinder, torus, any geometric model. This handling of objects, transformation principles, translation. Translation is nothing but you draw an image at one place, you move the image from one place to another place. That is called as translation. Left top la irukum or emblem, college emblem irukku, right top la irukku college emblem. Adha kondu enna pandren, left bottom la vaikkiren naan. Apdiye move panni left bottom la kondu vaikkiren. That is called as translation. Scaling அப்படினா அந்த emblem இருக்கு அதையே வந்து இன்னும் கொஞ்சம் பெருசாக்குறேன், less சின்னதாக்குறேன். That is enlarging or shrinking. That is called as scaling. இல்ல rotation. Rotationனா வந்து 45 degree அப்படியே slanting-ஆ திருப்புறேன், rotate பண்றேன். 90 degrees slanting, 180 degrees, திருப்பி அதே இடத்துக்கு வந்துரும், 360 degrees, right? So like that, we are using various transformation principles. Handle of motion. Motion அப்படின்னா the motion அப்படிங்கிறது வந்து movement of objects, that is called as animation. அப்படியே வந்து அந்த லோகோவை அப்படியே மூவ் பண்றேன், ஸ்டெப் பை ஸ்டெப்பா மூவ் பண்றேன். That is called as animation. Then handle of rendering. Rendering, image based rendering. Rendering சொல்லுவாங்க. ஒரு மூவி வந்து கிரியேட் பண்ணி முடிச்சதுக்கு அப்புறம் அது வந்து ரெண்டரிங் கொடுக்கணும் அப்படின்னு சொல்லுவாங்க. அது வந்து என்ன பண்ணுவோம், எடிட்லாம் பண்ணி முடிச்சதுக்கு அப்புறம் it will be combined together. That is called as rendering. Then how mathematics is used for computer graphics? What are all the essential mathematics for computer graphics? Trigonometry, polar coordinates. Polar coordinates எல்லாம் படிப்பீங்க. 3D coordinate system. ஏன்னா ரொட்டேட் பண்றப்ப வந்து பாத்தீங்கன்னா எல்லா டிகிரிக்கும் போகும். தென் கிராஃப் ஷீட்ல பாத்தீங்கன்னா குவாட்ரண்ட்ஸ் சொல்லுவோம், 4 quadrants, எல்லா குவாட்ரண்ட்டுக்கும் போயிட்டு வரும். தென் parametric representations, points, vectors, matrices. This is a right-handed system. The z-axis is coming out of the screen. Then left-handed systemல பாத்தீங்கன்னா z வந்து உள்ளார இருக்கு, அதான் depth. That is called as the depth of the image. Then components, 3D modeling, a way to describe the 3D world or scene, which is composed of mathematical representations of 3D objects called models. Then 3D rendering, a mechanism responsible for producing a 2D image from 3D models. So another 3D model or they are all displayed on the two-dimensional screen. Screen on the two-dimensional screen. Screen on the three-dimensional screen இல்ல. நம்ம 3 dimensional இதெல்லாம் பார்ப்போம், மூவி எல்லாம் பார்ப்போம். அப்போ வந்து பாத்தீங்கன்னா ஒரு ஸ்பெக்டக்கல் ஒன்று போட்டுவோம், ஒரு கண்ணாடி போட்டுவோம். அந்த கண்ணாடி போட்டு பார்த்தா தான் அது வந்து டெப்த் தெரியும். சரி, அதுல வந்து ஒரு ஸ்மால் லென்ஸ் இஸ் தேர் இன் தட் ஸ்பெக்டக்கிள்ஸ். தென் 3D ரெண்டரிங் நான் சொன்னேன், எடிட்டிங் முடிச்சதுக்கு அப்புறம் பண்றோம். Then 3D modeling, we are using mathematics. X square plus y square plus z square equal to r square is a model of perfect sphere with radius. Right? That is by using the Cartesian coordinate system. இது வந்து ஒரு இமேஜ், வரைஞ்ச இமேஜ், ஒரு ஜக் மாதிரி, ஒரு கெட்டில். Right? By drawing lines, by drawing circles, right? With a center and radius வச்சு வரைஞ்சது. And we are using rotation. Rotate பண்றப்ப பாத்தீங்க அப்படின்னா உங்களுக்கு இமேஜோட இது வந்து மாறும். ஒரு ஸ்கொயரை வந்து ரொட்டேட் பண்ணீங்க அப்படின்னா அது டைமண்ட் மாதிரி ஆகும். அதுங்களா, ஒரு ஸ்கொயரை ரொட்டேட் பண்ணீங்கன்னா யூ வில் கெட் டைமண்ட். ரைட்? ஸோ அதே மாதிரி இந்த ஹேண்டில் தான் பாத்தீங்கன்னா தேர் ஆல் ரொட்டேட்டட். சர்க்கிள் வரைந்து ரொட்டேட் பண்ணுங்க. ஸோ திஸ் இஸ் அ கார்டன். திஸ் இஸ் நாட் அ போட்டோகிராஃப். திஸ் இஸ் த drawn image. Okay? This is a drawn image. The drawn image அப்படிங்கிறது வந்து இந்த கலரிங், அங்கங்க வந்து ஃபிளார்ஸ் எல்லாம் இருக்கும் பாத்தீங்கன்னா தெரியும், ஃபிளார்ஸ். அண்ட் தட் இஸ் அ பாத், நடந்து போற மாதிரி ஒரு பாத் கொடுத்துருப்பாங்க. அதில் ஒரு கிராஃப், ஒரு இடத்துல ஒரு கலரிங் கொடுத்துட்டா போதும், ஒரு ஒத்தையடி பாதை மாதிரி தெரியும். அண்ட் வி ஹாவ் த ட்ரீஸ். அந்த லாங்ல போறப்ப பாத்தீங்க அப்படின்னா எப்படி அதுக்குரிய அந்த ஷேடோ இதெல்லாம் இருக்கு. ரைட்? இந்த ட்ரீஸ் கீழே பாத்தீங்கன்னா ஒரு ஷேடோ மாதிரி இருக்கு. ஸோ ஹவு திஸ் இஸ் டன்? Everything is possible, right? By using computers, and that is based on mathematics, right? So this is a glass. Glass la we are pouring water into the glass. தண்ணி ஊத்துறோம் கிளாஸ்ல, அப்படியே வந்து மேல வந்துட்டே இருக்கு. இதுல இந்த இமேஜ்ல பார்த்தா தெரியும் தண்ணி ஊத்துறத வந்து வரைஞ்சிருக்கிறது அப்படின்னு சொல்லி. தண்ணி ஊத்துறத பாத்தீங்கன்னா ஒரு ஐஸ் கியூப் மாதிரி தெரியும். இதுல தெரிஞ்சுக்கலாம் இது வந்து போட்டோகிராஃப் இல்ல, இது வந்து வரைஞ்சது. This is modeling, graphical modeling, right? Graphical modeling by using the Cartesian coordinate system. இது வந்து ஒரு கேம்ப் ஃபயர். நைட் வந்து ஒரு டூர் போறோம் அப்படின்னா கேம்ப் ஃபயர் போறோம். கேம்ப் ஃபயர்ல வந்து பாத்தீங்க அப்படின்னா நிறைய அந்த wood எல்லாம் போட்டு அதை பொறிச்சுடுவோம். தென் மோஸ்ட்லி ஆன் ஹில் ஏரியாஸ். இங்க வந்து ஒரு ஸ்மோக் வருது. இந்த ஸ்மோக் தட் இஸ் ஆல்சோ drawn, right? Smoke is also drawn, campfire is also drawn. எல்லாமே வந்து ஆப்ஜெக்ட்ஸ் தான், சரி, வரைஞ்ச ஆப்ஜெக்ட்ஸ். ஓகே, ஸோ ஃபார் கம்ப்யூட்டர் கிராஃபிக்ஸ், right, playing a vital role. We have computer gaming. Lot of games are there. சிமுலேஷன் ஆஃப் வெர்ச்சுவல் நிறைய கேம்ஸ்லாம், லூடோ கேம்லாம் இருக்கு, லூடோ கிங் இருக்கு, சாலிட்டயர் இருக்கு, வேரியஸ் கேம்ஸ் ஆர் தேர். இந்த பப்ஜிலாம் விளையாண்டு இருப்பாங்க பையனுங்க. இதெல்லாம் வந்து எவ்ரிதிங் இஸ் பேஸ்ட் ஆன் அனிமேஷன், பேஸ்ட் ஆன் மேத்தமேட்டிக்ஸ். These game designers must have the knowledge of the following to make the people, objects and environments behave realistically in the virtual. இதே வச்சு ஆடிட்டே இருப்பானுங்க பையன், தலையெல்லாம் ஆடுவாங்க. There is computer graphics, AI, human-computer interactions and simulations, software engineering, computer security. Then fundamentals of mathematics is useful. Laws of physics relating to gravity, elasticity, sound and light. அது ஒரு இடத்துக்கு உள்ளார டார்க்கா போறப்ப வந்து பாத்துல போயிட்டு கொஞ்சம் பப்ஜிலாம் விளையாடிங்கன்னா தெரியும். உள்ளார போறப்ப போக உங்களுக்கு லைட்டிங் வந்துட்டே இருக்கு, சவுண்ட் வந்துட்டு இருக்கு. ஃபயர் பண்ணீங்கன்னா சவுண்ட் வரும். Then probability theory, so the concept of mathematics. Then web designs, how the Google is working. It is on random walks. So a lot of servers are there, Again, a disclose algorithm will be used, and that is based on the graph theory technique. The vertices or the web pages with the directed edge from vertex X to vertex Y, if X has a link to Y. That is by using internet, graph theory irukku. Nadula, we are using the switches. This is how the Google is working. Graph theory. And finally, we have come to the end of this applications of mathematics in the digital era. Mathematics is called as queen of all sciences. How do you call the computer science? Because computers are built up based on mathematics. Right? So I did mathematics, I did computer science. Right? My graduation is mathematics, my post-graduation is computer science. So mathematics is called as queen of all sciences. Computer science can be called as king of all sciences. Right? And king is not superior. I should say queen is superior. Because all the kings are under the control of queens. Right? Thank you very much.
So thank you, sir. Thank you for your valuable special lecture, sir, for the applications in mathematics in digital era. So now propose a vote of thanks by Praveen. Praveen?
Yes, sir.
Okay.
Good morning to one and all. Together here on this special day, I am very happy to propose the vote of thanks. First, I would like to thank Dr. G.I. George Amalarethinam sir for his gracious presence and splendid talk on application of mathematics in digital era. Next, I would like thank to my head of the department and other learned professors for giving us opportunity to listen a wonderful lecture. Next, I thank our tutor Dr. Mohamed sir for guidance and his support. Finally, I thank all my friends. Once again, thank you one and all.
Thank you, sir.
Thank you. Thank you, Altaf.
Thank you, sir. Thank you. Thank you so much, sir. Thank you. ஸ்டூடெண்ட்ஸ், ஸோ இப்போ நீங்கள் மீட்டிங்கோட லீவ் ஆகிக்கலாம். நெக்ஸ்ட் கிளாஸ் வந்து ரெகுலர் என்ன டைம் டேபிள் காட்டுதோ அது மாதிரி நீங்கள் கிளாஸ் அட்டன் பண்ணிங்க. ஓகே, நெக்ஸ்ட் 4th hour வந்து என்ன கிளாஸ் அட்டன் போது நீங்க அந்த கிளாஸ் படி நீங்க அட்டன் பண்ணீங்க. ஓகேவா?
ஓகே சார்.
ஓகே, thank you.
ஓகே, thank you sir. Thank you sir.
Thank you. Thank you so much. Thank you so much. Thank you everyone.
Sir.
Thank you.
Thank you, sir.
Thank you.